Okay, this is Unit 9, Section 9.6, Solving a Quadratic by Graphing. So this is going to be the first instance where we are looking at solving a quadratic. Right now we have some tools in our toolbox. We've talked about the characteristics of a graph. We've talked about factoring in our previous unit. Our next unit in Unit 10 is going to be all about solving them. And so this is our first way that we're going to solve a quadratic, and we're going to use a method that's graphing in this unit. And so that will finish up our unit, then we'll get ready to review and test after that. So when we're looking at solving a quadratic, there's lots of names for the solutions. Sometimes they're called roots, sometimes they're called zeros, sometimes they're called x-intercepts. But all of these represent the same idea that these are the solutions to the quadratic. And so we typically will see solve this, solutions, find the solutions, something like this. And so the number of solutions depends on where the graph is. We've talked about this U-shaped graph that we can move around with transformations. We've talked about vertex form, we've talked about standard form. The solutions depends on where it is. So if I have a parabola that looks like this, here's two solutions. Those are our x-intercepts, where it's being crossed here. So I have lots of different ways that I could get 2. If I moved it over here, it's still 2. Moved it down, now I've changed where those are on the graph, but here would be 2. If I reflected this and had a flip up and down here, I'd still have 2 solutions. However, there are ways that I could get 1 solution, and that's where this would maybe come down and just touch once and then go back up. Now our solution only crosses the x-axis once. It just touches it and comes back down. And so if I move this all along the x-axis, this would be 1 solution. And again, just like before, I could flip this up and down. Right now there would be 2, but if I move it to the x-axis, this is another way I could create 1 solution. And on our third graph, there is a way that we could come up with 0 solutions. And so when we would have this one, 0 solutions could be something like this, that opens down and never crosses this x-axis. This would mean there's no solution. Or it could be, again, up here where it doesn't cross, somewhere over here. So as long as it doesn't cross, this would have 2. This has none. This has none, has 1, has 2, none. No solution means it's not touching. And so algebraically and visually, we can kind of identify how many solutions there are. Visually, we're just looking to see where does it cross this x-axis. Twice, once, or none. Algebraically, we can look in standard form. So if I have ax squared, let me try again there, ax squared plus bx plus c, and if I have this equation, I can check something called the discriminant. And the discriminant helps me know if there are 2, 1, or no solutions. So the way that we find the discriminant, d, is we take b squared minus 4ac. And so this tells me if I have 2, 1, or no solutions. And so if I get a positive number, so if I get a positive, there are 2 solutions. If it's exactly 0, okay, that's going to be 1 solution. If it's less than 0, so negative, then there are going to be no solutions. And so as we're looking at this pattern, our next 6 examples are looking at finding the discriminant and then determine not what the solutions are, but how many there are. All right, so can we find our discriminant? So this is going to be, I'm just going to write our formula down here so we have it. You have it right above, b squared minus 4ac. So b squared, okay, so I'm going to put that in parentheses, 5 squared minus 4ac. And so that's where I pulled the 1 here for A, 4 is the C here. So on my calculator, I'm going to go ahead and pull this up, get my calculator going, and I'm going to put this in all at once so that I can find the discriminant and then determine from that how many solutions I have. Is it positive, negative, 0? So on here, I'm going to go parentheses, not 8. We'll do 5 squared minus 4ac. Okay, so once I practice entering that in, I get a number 9. All right, so this discriminant equals 9. So because this is a positive value, they're going to tell me there are 2 solutions to this quadratic. If I graphed it, it would cross the x-axis twice. On number 2, let's find a discriminant. How many solutions are there? So I'm going to put my 1 in there again and then do b squared minus 4ac. All right, so on my calculator here, I'm going to put that in. So parentheses b squared minus 4ac. All right, enter that in. Ooh, I got 0 this time. And I kind of like that when we have d equals 0. Okay, this is going to immediately tell us there's 1 solution. There's 1 0 here. On number 3, all right, we're in standard form. We have b squared, don't lose that negative, b squared minus 4ac. Those all look like 9s, but those are 4s. And I can put that in my calculator. So don't lose the negative 12. So b squared minus 4ac. 4, 4, and 9. We got 0 again. All right, so just like this time, even though we have a different equation, the discriminant still is 0, which tells us there's going to be 1 solution. It's just going to just kiss the x-axis there. All right, on number 4, the discriminant equals opposite, so b squared minus 4ac. So again, I'm pulling that 1 in front of x squared. And then in my calculator, I have, don't lose the negative, b squared minus 4a, I forgot what c was, 10. So I'm just putting it in exactly as that looks, and I get negative 31 here. All right, so when we have a discriminant that's negative 31, negative tells us no solutions. So we can say none or 0. Remember, we don't know what the solutions are. We don't know where they are. We just know that how many they are. That's what the discriminant tells us. Okay, on number 5, we have b squared, don't lose that negative, minus 4ac. Don't lose that negative. And we can plug this in to see what the discriminant is. So negative 4 squared minus 4ac. Don't lose that negative there. We get positive 40. Okay, so a positive number. If we have a positive discriminant, that's going to tell us, just like 9 did up here, it's going to tell us there are 2 solutions. It's going to cross the x-axis twice. And our last one here, discriminant equals b squared minus 4ac. Man, my 4s are looking a little weak there. All right, so now we have, our b squared, so we have 5 squared minus 4ac. Negative 71, okay, so if we get a discriminant that's negative, okay, this is going to tell us no solutions, so none or 0 solutions. There won't be any place on the x-axis that this quadratic will cross over. All right, so we have practiced more vertex form as we were looking at our transformation. So today we're kind of going to review going back to our standard form, which used opposite of B over 2A. And so that will be something that we can use to identify some of these characteristics. So this is kind of the summary of everything that we should be able to find. Does it open up or down, max or min, axis of symmetry, the vertex, and roots. And remember, roots can be called solutions. They can be called x-intercepts. They can be called zeros. And so we want to be able to recognize this on our graph. So the first thing that I see is that it's pointing at the axis of symmetry here. This is our vertical imaginary line that says each side must match. Okay, here this is pointing at the solutions or the roots. They're pointing at where it crosses that x-axis. This is the very bottom, that's going to be our vertex. And the last point that it's pointing at, that's our y-intercept. That's where it crosses the y-axis. So this particular one opens up, giving us a minimum, a low value. The axis of symmetry is at x equals 1. It goes through x is 1. The vertex is at 1 and then lower, 1, 2, 3, 4, down. And the roots, that's why they're called zeros or x-intercepts, okay, we're going to have now over -1 up 0. So this is why they're sometimes called zeros. X-intercepts because we're writing them as ordered pairs here. And then this one, the other one we have is 1, 2, 3, 0. So this would have a positive discriminant. Whatever that value is, because there's two solutions, we would know that there has to be a positive discriminant. And so the next 4 problems here, we're going to be looking at solving these by graphing. And so we want to be able to find the roots by graphing here. And so the first thing that we're going to do is look for where does it cross this x-axis. So I'm going to graph it here. We have x equals opposite of b, so we're going back to this, divided by 2a. -4 divided by 2 is -2. And so if we find y, this is reviewing what we did kind of day 2 here. Okay, so I'm going to use my calculator, find this value. So -2 plus, let's square that, plus 4 times -2 minus 5. Whoop, what did I do? I didn't like it. Oh, that doesn't like that negative. All right, so we get a -9 here. So we know our vertex in the center is at -2, -9. All right, so I'm going to look at where that is. -2, -9, 1, 2, 3, 4, 5, 6, 7, 8, off the graph 9. Okay, now when we're looking for this, we're looking for where does it cross this x-axis. Those are going to be our solutions. Because this is positive, we know that this opens up, meaning it's going to touch once and twice. So I'm looking for 2 solutions here. All right, so I'm going to go ahead and see maybe it's on one of our values here. So I'm going to go up 1, 2, and down on the other side and see if we find them here. All right, so let's go ahead and put this in our table. So we're going to say table y equals x squared plus 4x minus 5. Create a table here. Let's go ahead and start at our vertex, -2. All right, so we have -1, -8, 0, -5. Okay, so this does mirror the axis of symmetry, so we do have those 2 sides here. So we have -1, -8, so we're going to be here. So 1, 2, 3, 4, 5, 6, 7, 8, and opposite side. And then we have 0, negative 5. 1, 2, 3, 4, 5. All right, but that hasn't told us where it's going to cross over here. So I'm going to go looking in my calculator because even though I have the vertex, I have 2 other points and their reflection, I have the y-intercept, I want to know where does it cross over here. And so on my calculator, I'm looking for where y is 0. So I'm just going to kind of scroll through here. And again, I got that pretty quick. 1, 0 is going to be 1 here, which means there should be 1 on the other side of it at 1, 2, 3, 4, 5. So again, I'm going to use my calculator, make sure that if I go to negative 5, that's my other 0. And it is. All right, so as I'm looking here, this is where it's going to cross once right there and again here. So now we have 5 points here, but not any of those did they end up being the x-intercepts, the solutions. We needed 1, 0 and negative 5, 0. And so those are going to be the solutions to this quadratic, meaning if I plug in 1, it equals 0. If I plug in negative 5, it equals 0. All right, let's look at number 2. Okay, so again, I'm going to try this by graphing, so we want to make sure that we are getting opposite of b over 2a. So opposite of b over 2 times 1, so 2 divided by itself. Y is going to be 1 squared minus 2 times 1 plus 1. So 1 plus 1, 2 minus 2, that's going to give us y is 0. All right, so we're at 1, 0. I'm going to go up and down and see if we can plot this. All right, so we're at 1, 0, and then we're going to go ahead and go to our calculator and get a graph. Look in here. So table, clear that out. We have x squared minus 2x plus 1. Enter. Let's start at our x of 1. Okay, they gave us the 1, 0, and then it's going to go 1, 4. Now, some of you might have already seen that as soon as I plotted that, did you see that was our x-intercept? As I keep graphing this, so go over 2 up 1, 0, 1, go over 3 up 4, negative 1 up 4. This is going to be one of those where the discriminant would be 0. It just touches the x-axis once. This only has one solution at 1, 0. Our vertex in this case ended up being the solution to this. And so this was one of those kind of special cases where the vertex is the root, is that solution. All right, let's try number 3. So we're going to do x equals opposite of b over 2a. Negative 2 divided by negative 2. Okay, that gives us another 1. And then y is going to give us negative 1 squared plus 2 times 1 minus 3. Okay, so this one gives us 1 squared is 1. Opposite of that is negative 1. Negative 1 plus 2 is 1. 1 minus 3 is negative 2. So I just figured that out in my head. So we're going to go over 1. Oops, sorry, opposite. Positive 1, negative 2. All right, so we're going to go up 2, 3, and down. And let's see what kind of values we get here. So now we have negative x squared plus 2x minus 3, and go ahead and start that at 1. That's where our vertex is. And so negative 3, negative 6 are the other two values here. Okay, so we're going to go positive 2, negative 3, and that means 0, negative 3. Positive 3, down 6, 1, 2, 3, 4, 5, 6, and other side. All right, so where are these solutions? I'm looking for where does this cross the x-axis? Notice this negative sign has made it open down, away from the vertex, and because of where our vertex is, It never crosses this x-axis. It won't cross it. So in this case, visually, I can tell there are no solutions. There are none. And our last one, okay, I'm going to rewrite this so that I can see all the values. I have the negative x squared, but I'm going to go ahead and put plus 0 x's because there's not that b term there, plus 4. All right, so then when I'm solving, I'm going to say x equals opposite of b over 2a. Okay, anything 0 divided by anything is going to give us 0 here. And so y, when we plug that in, negative 0 squared, still 0, plus 0 times 0, still 0, plus 4. All right, that's a lot of 0 plus 4. So our vertex is going to be at 0, 4. 1, 2, 3, 4. And then we're going to go up 1, 2 and down 1, 2. All right, so let's plug this in, see what other values we have in our table. So I have negative x squared plus 4. I could write plus 0x2. It would give me the same thing. I'm going to start my table at my vertex 0 so that I have 3, 0 going up and 3, 0 the other way. All right, so now I have over 1 up 3, and then I have negative 2, 0 and positive 2, 0. All right, so each one of these was a way to find the solutions. The first one we had to use and extend our table. The second one, our vertex was the solution. The third one never crossed. This one ends up being in our table. We used our 5 points and ended up with the solutions at 2, 0. It crosses here. And at negative 2, 0, it also crosses here. This would have a positive discriminant, giving us 2 solutions. All right, so this will wrap up our unit, kind of looking at graphing and solving. Another characteristic of that graph is where it crosses the x-intercepts here. And so that's where we want to be able to identify those points specifically, using our graph, using the table as ways to kind of help us see that. Let me know if you have any questions.